Okay, so from this point forward, we're going to actually calculate confidence intervals utilizing all the steps and procedures necessary to get a 5 on the AP exam, or at least a 4 on these particular problems. There is a very strict grading rubric. You need to follow these recipes step by step. So the very first thing says define the parameter mu in context. In other words, the population mean in context, what it is we're looking for. And notice we're defining the population parameter, not the sample statistic. So the population mean. So we're talking about the population. We always have to write our conditions. And while it's a pain, we're going to have to do this. We're going to start off with random sample. Typically, that is given in the problem. If it's not given, we will say that it's assumed. So we're going to be looking for a random sample. N is less than 10% of the population. In other words, our sample size is less than 10% of the population. A lot of times we won't know the size of the population, and we'll just have to say that it's assumed that that is the population is 10 times larger. This comes back to, at the beginning of the year, we talked about having a massive pile of M&Ms, and if we took one away, the percentages changed. All right, but they only changed slightly. So this is kind of testing independence. It's saying, you know what, yeah, the percentages changed, but it only changed slightly, so we didn't worry about it. We said that it's reasonably independent. It's basically what we're saying. So the purpose of this is to say reasonably independent, because we're sampling without replacement. Okay. We have to have a normal population, or N must be greater than or equal 30. If data is given, we're going to have to draw a box plot or histogram to show normality. Because typically, if data is given, we're going to be given a very small sample set. So normal population, N greater than 30, or we're going to have to draw a box plot to show normality. We're going to write our equation, which is x bar plus or minus t star s divided by the square root of n. X bar being our sample mean. T star is the number of standard deviations and is tied to our confidence level. S is the sample standard deviation, and N is the square root of our sample size. All right. Really, we don't have to graph and shade, but I am going to say this right now, that typically if we had a 95% confidence level, we're looking for a lower bound and a upper bound. We're looking for those two values. And also I want to talk about the confidence interval is a two-tailed test. So this is known as two tails. And the area in the tail is alpha. All right, for the time being, we won't worry about that. In this case, if we had a 95% confidence level, our alpha, the Greek letter alpha, would be 0.05. Not a big deal at this point. We'll talk about that later next week. Then we're going to enter the data if it's given. Most of the time, they're not going to give us data, and we'll identify all of our inputs, calculate our T star, and this is the way you do that. Plug in the values, and we have to show our plug-in into the equation. This is critical to plug into the equation. And then we're going to calculate the interval using this. And then we're going to write our conclusion. And our conclusion is going to always look like this. We are blank percent. And if we were 95%, we are 95% confident the true population mean, whatever our definition was that we gave above, lies within the interval lower bound, comma, upper bound. Sometimes it'll ask us to explain the meaning of the confidence level. And basically we'll say, in repeated sampling, we expect that this method will capture the true population mean of whatever our definition is 95% of the time. Okay, so here we go. Let's look at our first scenario. So a publishing company has just published a new college textbook. Before the company decides the price at which to sell a textbook, it wants to know if the average price of such textbook in the market. That makes reasonable. Hey, how do other textbooks, what are the prices for other textbooks that are similar. The research department at the company took a random sample, so okay, that's important because we know that that's one of our conditions of 36. So in this case, we know our sample size n is 36, which means that regardless of the price of regardless of the distribution of the prices, the distribution of the means or the sample means will be normal by central limit theorem. The information produced a mean price of $70.50. So we now have a sample mean of $70.50 with a sample with a sample standard deviation of 450. So they're telling us the sample standard deviation is $4.50. All right, the fact that we're using the standard deviation of the sample lets me know that I need to be working with a t distribution. And it says construct a 95% confidence level interval for the price of this type of textbook. Well, what are we interested in? We're interested in the price of the textbook. So the very first thing we do according to the recipe is define the parameter mu in context, mu being mean. So here's the way we say it. Let mu equal the true population mean price of college textbooks of this type. You absolutely have to write that down, right? Can't abbreviate it. There's really nothing, no other way around it. You're going to have to do it like that. The next thing we're going to have to do is our conditions. We're going to have to random sample. N needs to be less than 10%, and we need a normal population or N greater than 30. Well, the first condition was random sample, and they told us it was a random sample, so that's given. So we just write random sample given. The next thing, it needs to be less than 10% of the population. Well, our sample size was 36. So 36 divided by 0.1 is 360. That's the way I typically do this, is just like this. And I go, it's reasonable to assume that there are 360 textbooks of this type out on the market. All right. I don't know if it's really reasonable or not, but we're going to have to assume that there are so that we can proceed. The next thing, we need to check normality, the normal condition. And this will always have to check normality in some form or fashion. And we don't know that the population is normal, but we know that our sample size is 30. It was 36, which is greater than 30. So n equals 36. The distribution of the means is normal by central limit theorem. So now I've addressed my conditions. This part is worth one of the 4 points. That's worth one of the 4 points. And if you're missing more than one element, you get no credit for it. Okay? So the next thing I need to do is write down my equation, which is x bar plus or minus t star s divided by the square root of n. Now, what I always start doing is I start plugging in. What do I know? Well, I know that my sample mean is 70.5. So I'm going to write that down, 70.5 plus or minus. I don't know my t star yet, so I leave a blank for it. I know my sample standard deviation is 4.5. And I know my sample size was 36, so divided by the square root of 36. Okay, at this point, I'm going to go back and I'm going to calculate my t star. All right, so t star, we go and get that by doing the second var's inverse t on the calculator. Second var's inverse t. And we said we wanted a 90%. So parenthesis 1 minus 0.90, close parenthesis, divided by 2. Degrees of freedom, which in this case was we had a sample size 36. So 36 minus 1, or you could just type in 35. And I end up getting a t star of 1.689. All right. So my t star, sticking to the paper, 1.6895. All right, so now I've plugged in my work and I'm ready to actually calculate this. All right, Now I can do this by going 70 minus this and then 70 plus this, but I much prefer to go about and let the calculator do other work, which will be stats, test, scroll down to number 8, T interval. And in this case, my mean was 70.5. My standard deviation was 4.5. My sample size was 36, and I wanted a 90% confidence level, so 0.90. And I get 69.23 to 71.77. So now I've done all my computation work. And by the way, this part right here typically is only worth 1 point. So all this work right here is typically worth 1 point. Then we have to state our conclusion, which is worth a point. And in this case, we are 90% confident that the true population mean price for college textbooks lies within the interval 69.23 to 71.77. And that will get me full credit for that part. If they ask me to explain the meaning of the confidence level, I'd say in repeated sampling, we expect this method will capture the true population mean price of textbooks 90% of the time. All right, and that would take care of that. And really, there's usually some other question, because this right here is typically worth 1 point. Usually they have some other question to make it up to 4 points, but that will get you at least 3 of the 4 points. And usually, like I said, there's some other question that goes with it. So using the above problem to calculate a 95% confidence interval. Well, we've already written down and defined it. So let's just go ahead. All we're going to do is keep everything the same, but we're going to recalculate the confidence interval or the confidence level, the T star. So we need to recalculate a T star. So here we go, second vars, inverse T. And now my T star is going to be 95%, so parenthesis 1 minus 0.95, close parenthesis, divided by 2. Degrees of freedom are still 35. And I end up getting 2.03 for my confidence level, or for my T star. And I need to run this, and I go stats test down to number 8, T interval, stats test to number 8, or T interval, and I got to change my confidence level to 0.95. And I end up getting 68.98 and 72.02. Notice we're getting a little bit, this is a little bit lower and this is a little bit higher than what we had before. Why? Our confidence level went up. And then we're going to do the same thing with a 99%. Well, everything's the same, except we're going to need to recalculate our T star. So second vars, inverse T, and we're changing our confidence level to 99%. Parenthesis 1 minus 0.99, close parenthesis, divided by 2. And I end up getting 2.72. And then finally, we're actually going to go ahead and run the test. Stat test, drop down to number 8, T interval. Change our confidence level to a 99% confidence level. And we end up getting 68.46 to 72.54. All right. Once again, we're a little bit lower and a little bit higher. So this is lower than that and it's higher than that. So we're getting wider as we go. So what do you notice about the 3 confidence levels? Explain the difference. As the level of confidence increases, the T statistics increases and the interval width increases. All right. So the T statistic increases and the interval width increases. Most important part is to know that the interval width increases as the confidence level increases. So as the confidence level goes up, the width also goes up. All right. Thank you for watching. Hope that helped.